I'm going to show you a few different ways to do grade crossing flashers and how to adjust the speed of them. So let's get going with this right now. I'm Tom Kovichak, and this is Tom's Trains and Things. This channel was created to help other modelers who are in need of guidance in pursuing their dream of building a model railroad. Now, I showed you how to do a crossing flasher in Arduino, and it was really simple. It was just changing a couple of lines of code, and there we go, flashing on there. But now I'm going to show you how to do it with a 555 timer chip and a couple of resistors. I'll show you how on the fritzing diagram and the wiring diagram, what they look like. You can see the components on this video on the wiring diagram that I have listed at the end of the video. And the fritzing diagram will be there also on the two projects that I did. I actually did 3 different projects, but I only settled on 2 of them. So take a look at that at the end of the video. If this is your first time here or a returning viewer and you would like to see more videos like this, go ahead and hit that subscribe button. And while you're at it, ding that bell, and that'll notify you whenever I have a new video coming out. And speaking of videos, go ahead and check my playlist. You can see a lot of different videos in every category about model railroading in my playlist. So go check that out there. I have over 40 playlists in there with over 280 videos. So check that out. So let's get going and see how we do these flashers. I have a 33 microfarad capacitor hooked up to this right now. And you can see how fast it's going. Now, if I put a 47 microfarad capacitor in there, it's going to slow it down a little bit. So that's the 33. Now this is the 47 microfarad. And this is with the 555 timer chip. Now, we're doing the same thing with this circuit right here with 2 transistors, 2 capacitors, and 4 resistors in there. And it does the same thing. And let me hook that one up. But this is a little bit slower, so we can adjust the speed of that. Right now, I have in this diagram, it says 10 microfarad capacitors, and that's how it's hooked up. We got the 2 transistors. I got the capacitors going across the transistors from the collector to the base with the 470 ohm resistors right there, and that controls the brightness of the resistors. Now I got 200k ohm resistors on the base. If we try to reduce the 100k, we could see what that does. Using the resistance substitution boxes, I have one over here, the box, and then I have this one here. Both of them are set at 68k. Now that goes a little bit faster. Let's see if we could bring it down, or bring down the resistance a little bit more and see how fast it is. We'll go down to 47k. And see how that does. You can see I have the resistance substitution box on here, and that was just to check different resistors real quick without trying to pull out resistors and everything else. Just flip the switch and use jumpers on the other one. That makes it a lot easier instead of having to go and change components on your breadboard. Now that's at 47k. So you can see on this one here with the transistors and the capacitors, changing the value of the 2 resistors on there that go to the base of each transistor. As you decrease the resistance, you increase the speed of the flashing. And on the other one with the 555 chip, you do that with the capacitor. I have both of these circuits running pretty close to, but not quite. On my resistance substitution box, I only have, like right here, I only have 47, 68, and 100 that I could choose from. and right now I have it at 47. And then over here on the capacitors, what I'm using right now, let me see, this one's the 33. So I'm using the 47 microfarad capacitor on that one with the 555 chip. Now they're close, but not exactly the same. These are a lot harder to build than what we did with the Arduino. You saw with the Arduino on Saturday how easy it was with just some code to flash the LEDs. Although this one works and you adjust the speed with the capacitor right there. I'm going to try a different design which uses two capacitors, but the speed is adjusted by the resistor that goes between 6 and 7. So I'm going to change this design here, pull all this out. I'm going to keep these LEDs here and just change this around right here with these resistors and the capacitors. We're just going to have to change these around. The jumpers are the same from 2 to 6 and from 4 to 8. And then 1 goes to negative, and then 8 goes to the positive. And 3 is where your LEDs come from. And it's split, your LED and resistor split from one goes to the negative and the other goes to the positive. So when it just flips back and forth. When one is high, the other one's low. Now this circuit right here that uses the two capacitors, both the negative side of the capacitors go all the way to ground. This one right here, the 22 microfarad, goes between the plus and the minus leads. And we use the resistor here. There's a 2.2 k ohm resistor between pins 7 and 8. And then between 6 and 7, there's a 47 k ohm resistor. And that's the one that adjusts the speed. Now, the 47 k ohm is the 747 k ohm that I'm using on that circuit right there. So we could use both of these circuits with 47 k ohm and adjust them by the resistor in the circuit. I like this circuit better right here. This one is off of a 9-volt battery. Okay, this one over here is off of 12 volts. I'm going to put the 9-volt on here and see how it works. I played around with several different designs on there and came out with the best one to use. The last one with the 555 and the two capacitors on there and the 2.2 and the 47k resistor, I think is the best one to use with the 555 timer. And the one with the two transistors on there and two capacitors, that's a good one also if you like doing it that way. But those are the two best ones that I have found. There's many ways that you could do it. I searched on the internet and I've seen about 5, 6 different ways to do it with the 555 timer. And the one that I have right here, I think is the best one to do. You can make your own decision on that. These two that I chose are the best ones for me, but it may not be for you. So go ahead and check out, see, there's other designs that you could find on the internet. Okay, now I have both of them operating off of the 9-volt battery right here. The only thing I changed on this one, I had 220 ohm resistors on there, but I have a 1k ohm resistor on each one of these LEDs, and it seems like the same brightness as it was before. Over here, as you could see, we have 470k or 470 ohm resistors on these LEDs right here. But we could add a second set of LEDs on, second LED on each one of these, and it'll still work. Let me pull one off of each one of these. And we'll just show you how it is with one on each one. So there we go. We got both circuits right there. But there's our flashing circuits. Two different ways of doing the flashing circuit. One with a 555 chip and the other one with, I think these are 3904 transistors. You can also do them with 2222 transistors. NPN transistors, and you got two capacitors here, you got two capacitors here. These capacitors here are 10 microfarad. These ones over here, you have 10, this is a 10 microfarad, and this is a 22 microfarad that goes from the positive right to the negative. Two different flashers, two different means of getting the LEDs to flash. One with transistors and one with an integrated circuit, the 555 timer. And I got both of them so we can adjust them with the resistors in the circuit. I tried one circuit, and you have to use a capacitor to do that. This is the transistor diagram, and the only thing that I changed on here is the 100K resistors. I reduced them down to 47K to get the LEDs to flash a little faster. Now on this fritzing diagram, I reversed the transistor on the right. So the left transistor, the flat is facing you, and the flat on the right transistor is away from you. You'll notice that the emitter on both transistors are on the outside with the black wire going to the negative rail. On this 555 timer chip circuit, I left everything as is. So the components you see on here are the same components that I used on my example. Since you can't stand resistors up on end on the fritzing diagram, I have the two resistors on the blue and yellow wires laying down, but they are the same as in the breadboard in my example. You have to be very careful when using electrolytic capacitors because they have a polarity on them. So if you hook them up backwards, you'll have very bad results. They can be severely damaged. You make sure that you have the plus on the plus side of the diagram and the minus on the minus side of the diagram. They're clearly marked on there. They have a silver band or a white band on one side that has the writing on them. So that's the negative side of the electrolytic capacitor. I gave you several different designs of the flasher in this video, but if you would like to activate and deactivate, it's as simple as this battery here with a switch. You could use your own activation in your track or however you want to do it, but it's just like interrupting the power with a switch. That's all it is. And we'll cover something like that in the Arduino later on when we get that far in the Arduino made easier. And we'll see you.